Yes, we are live.
Okay.
Hello, everyone. Hello, everyone. I welcome you all on behalf of Amadis Technologies back again with another impactful webinar series. And this time it's on hot topic of these times, Gen AI. This Gen AI webinar series, we are starting off with decoding Gen AI cost structures, the critical aspect, what all the industry practitioners are running after. So we are all excited for today's topic because a couple of our agents that we have developed, it is already successfully running in some of our client plays and driving a lot of value. So it deeply resonates with us. Saying that, let me introduce the speakers for today. We have our very own founder and CEO, Madhu Kumar, and Raksha, one of the key members from our GenAI Excellence team. Hello, both. How are you? Why don't you wave at the participants and say some
Thank
words?
you, Sindhu. Thank you, Sindhu. Nice getting us here.
Thank you, Sindhu.
All right. So, with that said, let's get into the agenda. I would like to start this session with a couple of statistics, shocking statistics also. So, in the next 5 years, according to Bloomberg, the AI spend is expected to exceed $1.3 trillion. dollars. At the same time, according to Gartner, 40% of the AI projects are expected to be cancelled. One of the major reasons, cost drivers. Cost budget overrun. These are the this is one of the major reasons. So, how to find a balance among this dilemmatic situation? That's what our speakers will walk you through in the next 30 minutes. So, we'll be having a Q&A session towards the end. So, do post all your questions in the comment box. Our speakers will take them up. That said, let me get into the agenda for today. So our expert will start with Gen AI basics, the fun a little brush up on the basics. He'll start with the token, the concepts, models, and all that. Then he'll slowly segue into the hidden cost drivers, what's happening behind the screens, followed by the agent economics, the key topic of today's session. Then our expert Raksha will walk you through the model selection process because we know a lot of models, GenAI models available in the industry. She'll pick the popular models and tell you how you can select the right one for your business use case. So let me invite Madhu to begin the session. All
Thank you,
yours, Madhu.
Sindhu. Yeah, thank you. Thank you very much. Hey, good morning, good evening, wherever you're logging in from. When you get a chance, please enter where you're logging in. That may give you an idea that whether you're in a morning zone or the evening zone. Anyway, coming back to fundamentals, I thought for all of you audience today, over the last 3 years, you may be hearing so many terms because right from linear processing, linear algorithms, when this generative algorithm started becoming popular post pandemic with GPT Federation, this entire work of what kind of business process, how this generative algorithms work, oh man, you would have heard a lot of terms. I thought over the next 2 minutes, I hope the audience, you are fundamentally step one aware that how generative algorithms create new original content. When it creates a new original content, token after token or pattern, it is based on patterns, the structure of your training materials, as well as the what I call statistical probability. So generative algorithms are traditionally a probabilistic algorithms creating new original content which can be used for decision making processes. So that's how the algorithms work. Coming down to the algorithm, the mechanism and process is you would have heard about training neural networks, learning patterns, and inferences. Certain algorithms also does back propagation. So this is, hey, I based on pattern, structure, statistics, the algorithm is giving you new content, but it actually back propagates saying that, oh, is it correct or I'm learning more and more. Then the third important point is the common type of gen models. Wherever I go, whichever place where we have been, as Sindhu mentioned, we deployed a couple of agents. The selection of what type of agent, what type of transformer model, or is it diffusions, or even simple GANs, or finally you have to go to variational autoencoder. So these things do matter a lot. If you pick the wrong model for the right work, there are challenges. We will talk about it. Then the fourth and the fifth are very simple. When you generate new original content, these algorithms take trillions of rules and they call it as chunks and tokens. Then, based on the tokens, it creates a latent space, as well as you would have heard the word temperature. I'm hoping you all learn these terms. You can ask any ChatGPT or anything, they will tell you. So, these fundamentals, how algorithms work, the core mechanisms, the common type of gen models, generational concepts, once you're clear about it, then you can go back and look at and say, okay, for this business problem, for my customer, for my unit, how do I realize it, envision, actualize, and launch? That's the way we call it, real implementations for GenAI agent models. In the future series, we will talk about the details of real. Today, we are completely talking about GenAI fundamentals. When you actualize and launch it, you have to be careful about potential hallucinations. The most important thing for today you will see is the resource requirements for training. A little bit of bias and transparency for regulatory is also key metric. So if you cover these five things, most 99% of implementations will go from, as Sindhu said, from R&D to production. There is a steep drop. There was some reports you would have seen a couple of months back that only 5% of uh, proof of concepts went into production. It may be a little exaggeration, but I think we also see within the client's last couple of years, we see a substantial less movement of from proof of concept to production, but not as low as 5%. But that is there. But the way I want to tell the audience today is if you do completely chart down algorithm working, mechanism, common types of gen models, generational concepts, and the limitations of real is a separate topic. But if you cover the first four, you will have a very good generative algorithm implementation for business flow. With that, let me jump to the next slide. Yes, this is the core focus of today. Even though we learned the fundamentals, when you look at implementations, Sindhu also mentioned, you would have heard, we are seeing that the cost of tokens in a federated LLM model or the cost of the entire systems in a non-federated LLM model, everything moves like a hockey stick. Why? We will talk about it later on. Most of the times, we just created this graph. The actual graphs are a little bit, up and down. But for the ease of use and understanding, from pilot to production, when large data sets and enormous amount of users come in, either if you are in a federated on a LLM, which is on a token pricing, or if you are using your own GPUs and your own hardware, your own systems, your compute capabilities are going to be at a very, very thick stronghold. So within both ways, the equated cost of running the models for the real production is actually, in one or two cases, we're taking a little bit of hockey stick model. It really exponentially moves. That is an area where one has to be careful. But if you take care of the first four elements, then you really know how to give context and how to take care of the pricing alone. We will talk about it. Okay. With these two slides, why don't I go to the next one, Sindhu, where a bit of housekeeping again. Now we are into the topic of token math. Okay. The way all models, whether it is generational algorithms, inside the system or outside, the context window is an important topic. Based on the model tier you're picking, As long as you give the context properly and keep it in memory and keep on doing it step by step, the amount of tokens you're feeding it in or the amount of tokens you're getting out, the next text, is limited. The very, very important element, Raksha will talk later on, is actually input tokens are priced lower. The output tokens are the most expensive. So you may be getting excited with, oh my God, I'm getting a big response from my generational model. The more response you get, you should be very clear that you don't want too much text on the response. You have to be extremely intelligent and, we call it as the prompting strength. You have to be very, very conscious about what you ask. But it's not that I want to, put a fear in the mind of the generational AI engineers. Uh, in a relational world, if I pick, in the old world linear algorithms, people used to think, how do I manage memory? How do I manage compute? How do I manage my entire algorithms? Am I doing too much of looping inside? Or in a database, am I indexing it properly? So there are so many things an engineer thinks in software engineering. Very similarly, when you use a generative model, I also think the mind of a generative AI engineer should understand the model, which is the most difficult one. There are a bunch of models, you saw it in the first slide. Then look at this particular model you're deploying, how it will behave. Then you give the prompting properly. So the context window, the model tiers, and that leads to the input and output versus gap is very crucial in terms of the mathematics for the cost of running the model. Then comes the issue of language and format, agent fanouts, retrieval corrections, tool API innovations, embeddings. These five things in a single way really fall under the first three categories. Once you look at all those, once you master that, train yourself, write, plan, context, I think the Gen AI engineer or your data engineers or people who are practicing generational algorithms for business flows, you will be very authoritative. You can be confident that I know what will be my token math for what kind of things. Because when you saw the graph earlier, it is going up, but as long as you can predict it is going up, the company you work for or the business unit you are deploying it, they are okay with it. It is one when generation algorithms start giving you unpredictable cost figures. That is when all the business leaders and everybody gets worried. So if you can predict, if you can think of looking at how it behaves, these parameters will give you the math unfold. I hope I didn't confuse the audience, but it is that look at the model, look at the way it is working, take care of the context, take care of the model timings, input parameters, output parameters, the way it is working, how quickly it gives you results. I think you should be a very, very, very confident Gen AI engineer. That's the way with Sindhu. I think next slide is very small one. This one is before Raksha is going to talk to you about model selections and a little bit of complexities. You should always look at any Gen AI engineer when he's running. There is a token price, but there are latency issues. The agentic model, when we launched a couple of models earlier, the retry is an area where people use RAGs and other things, but a couple of models and potential retries are a thing which can boomerang without you understanding it. So you have to watch every prompt, every trigger. Does it making a continuous chain or simple models? Now, will each agent introduces tokens, latency, and retries? The entire model control protocol, the orchestration needs may create a nonlinear cost growth based on how many models are using, how many tokens, and how many outputs you're reading for the further ones. So once you are clear about the user request, the orchestration, and the last one is cost scales with in depth, not the usage volume. That is more of, I think in the future things we will cover more and more. It's only a teaser for you to understand that the architecture depth matters more than usage volumes in a contrary thinking. People think that if I use more questions, more things, my cost may go up. No, if your architecture is also not properly scaling, you may have a higher cost figures. Okay, so that's all I wanted to cover today, Sindhu. The model, the fundamentals, the way it is doing, the tokens, latency, and all these potential retries. With that, I hope I can hand over to Raksha, or Sindhu, you have any questions? If you want me to answer, I'll do it. Otherwise, let Raksha continue.
Yeah, thank you, Madhu, for the brief coverage. As of now, we can still move to Raksha. Probably towards the end, I can post all the questions to you both. So, Raksha, it's your time.
Oh, it's a fairly complex.
Thank you for the introduction, Sindhu, and thank you for your introduction, sir. So, while viewing into this slide, you might have a question that why model selection is very much important when you can choose a smartest model in the market. But while we move from production to development to production, we don't think that how smart the model is, but we have to think whether the model balances the cost, speed, and accuracy. So consider you want to deliver a letter to someone. You will not take a semi-truck, right? You will just use a scooter or bike to deliver a letter. Likewise, for simple FAQ chatbots, you will not use large models which cost millions of dollars. So now let's dive into model selection matrix. So consider your situation that your organization want to develop a business analyst chatbot. So where you can provide 50 pages of document and want to get key insights. So what was the model you might choose? It's large language models. So from the slide you could view that some of the example models were provided: GPT-4, GPT-4.1, and Claude 3. So the major cost drivers for this LLM are just token context window. So tokens are, as Madhu said, that token prices were calculated based on input and output cost. So input cost is much more cheaper than output cost, and output cost is much more larger. So the only way to reduce this token cost is prompt optimization in large language models. So prompt optimization is nothing but consider a scenario you're writing a prompt, right? Could you please make it accurate answer? Instead of that, you could use the keyword accurate. That's the way you could optimize prompt. Any other ways you could use a certain number of tokens that you want expecting from that model. You could provide that I need this number of 258 tokens of output from this model. You could provide what number of token that can be get it from the GenAI. And next, catching. And catching is one way that if you're asking the GenAI several questions at the same time, that means if you are asking GenAI repeatedly the same question. So we are using, Amadis have been working on a image comparison project, and in that also we could use catching. But the only problem in catching is it will if we are not using it entirely. For it was the cost pricing was entirely based on 1 hour. We have to pay for 1 hour instead of number of tokens provided. And next, consider a situation if you are developing a customer support chatbot, and exactly for that you will choose a small language model. And same as large language models, the major cost driver for small language models is also token. So the only way, but the only point that which makes SLM better than large language model is cost efficiency, because as you could see that GPT mini model's cost is in the input cost of the GPT mini model is $0.16 and output is $0.60, which is very much cheaper than other models, which costs around to $6 of output cost. So if you consider a situation that if you're developing a GenAI agent for bank want to implement AI, which processes the important internal data of a bank, which is confidential, which should not be shared to a language model. These details can be handled by open source LLMs. So the major cost drivers are GPU storage. So the examples are 𝐊𝐞𝐲, Mistral, and Falcon. So you have to download this 𝐊𝐞𝐲 in your system, and you could run that small language models within your local system. But the only thing is that the GPU of your laptop should support this model, and it may take large number of storages around the GBs of data. And when we are moving into production, we have to host it in a cloud. So while many number of users come into the cloud service, we have to auto scale it so that the number of tokens will so the usage will be increased, the price amount will also increase. This is the main cost drivers of open source LLMs. So while the only way to reduce the cost of open source LLM is just auto scaling it. And next, if you're developing a GenAI model for image generation, that means your marketing team want to generate large number of images for the advertisements or something. You just want to move on to image generation models. So image generation model, you know that the DALL-E is the famous model that was released by OpenAI. So the major cost driver for this DALL-E is the images generated by it and the resolution of the image. For example, if when you are generating an image in Copilot, you could see that at a time 3 images will be generated. So it might cost you a lot. So while giving the only way to reduce this kind of increase in cost is just give it as a prompt. I need one image. Just one prompt can change the large number of it can reduce a large amount of cost that you have to pay. And if you want a smart assistant where you could compare images, and you want to consider a situation like in our childhood we could play a game, right? So matching the finding the differences in the images, and you could use this multimodal likewise though. So the model, you could give two images where you could give the prompt that compare these two images. So the model will give the differences between two images. This is one of the example I could tell. So for this, you could really rely on multimodal models. So some of the example models are GPT 4.0 and Gemini 2.5. So Amadis have been using this multimodal model for our new projects, and it is working really good. And the major cost drivers are exactly tokens. So you have, I just want to share that the token pricing of Gemini 2.5, which is much more interesting in image comparison. So consider a situation that your image is 1024 into 1024 pixel. So how the Gemini will calculate the token prices? Just if the pixel value is greater than 384 pixel, it will just scale up to 768 pixels. You just want to divide into a pixel rate, that is 1024 divided by 768, which is nearly 2 point something on something. And if you multiply this 2 and with this same as 1024 divided by 768, you will get 2. And the cost price is entirely based on tiles. So the 2 into 2 tile is just exactly 4. And for each tile, the Gemini 2.5 Flash costs about 258 tokens. So which is around 1032 tokens. This was the cost calculation by Gemini 2.5 Flash. Similarly, GPT 4.0 have their own cost calculation method. So likewise, we have to choose which model gives you low cost, and you have to understand the purpose of the model you are choosing. And the FinOps impact for these models, for multimodal models, are if your project is running successfully and it was solving many of the problems at the same time, that means it was saving you most of the time, means you should not consider the cost, right? So this is the only way. If it is useful for you or for that particular project, you have to move on into multimodal models. And next, consider a situation you are developing a model for a company which want to transcribe their speech. That means your company employees were native in English, but the developers in other countries were native in other languages like Spanish. But if you want to convert that language into a language, you just use the speech models. So some of the speech models include Whisper, Amazon Transcribe, and Google Speech, etc. And the Amazon transcribe cost $0.024 per minute. So the entire cost calculation of the speech audio models are based on the audio minutes. So the how much time the audio is running, and the sampling rate. Sampling rate is nothing but the time you're taking to convert the analog signal into digital signal. We are converting the value into digital values. This is the major cost drivers, and the cost of this audio models are nearly predictable. So you will know, right? This much amount of the audio will run for this much of time. So you could easily predict how much cost you could get for this model. And next, so this is the major thing that every IT companies were using code generation models. So if your company want to implement a developer, if your company want to bring inbuilt AI tool in your IDE, example, using VS Code, you want to implement a developer tool for the GenAI model to the IDE, you just move on to code generation models. So code generation models are very high cost. So these models include GPT-4 Turbo, Code, Llama, and Star Coder. So the major cost drivers are token volume and IDE integration. So why IDE integration costs you a lot means, when you are integrating into the VS Code, every time when you run a code, it will give you a code suggestion. So when it will give as you could see that when the cost driver for the generation model is nothing but the output tokens. So it will generate more as every time it gives you suggestion, the output tokens will be increased, and your final price will be very much large. And if you are using the same model for all your tools, exactly many number of developers will be using that at the same time, and the price will be enormously large. And this is the cost for code generation model is can be calculated, but this is where we can use this code generation model is to review your PRs. So when while reviewing the PR, the time will be saved for you, right? So as the team leader or someone, if you are reviewing the PRs of your developers, the time will be saved exactly. And this is the only way you could reduce the you will not consider about reducing the cost in that situation. You just want to think that whether it is saving your time, which is increasing, whether this models are increasing their productivity or something. These are the major cost conditions we have to check on it. And next, we can move on to the next slide. Sindhu ma'am, could you please? So this is model selection scorecard, which you can use to select your models. So first, you could use that model selection matrix. Yeah, if anyone, Sindhu ma'am, could you please want to code selection matrix? Yeah, if anyone want, you could take a screenshot of it so that you could use it while selecting a model.
No worries, Raksha. At the end of the session, probably after the session, we can share this model selection matrix as well as the scorecard to all the listeners. Don't worry about it.
Okay, sure. So coming on to model selection scorecard. So first you have to consider that what is the purpose you are using the model. And the first test was faithful test. So if just provide a document into your model and ask 5 questions, which the answer for the questions you should be known, right? So if it answers all the questions correctly, you just score 1 point for each questions. And calculate the score for both model A or B. You could choose any model, example GPT 4.1 or Gemini 2.5 Flash or Claude 4.5 Sonnet, any models. And if it and next question is the test is JSON test. So ask the model to provide certain type of output. So you have to ask the model just provide a output in JSON format. And just score your questions. If it provides accurately in a JSON format, you could give 5 marks. If not, you could reduce the points. And next, speed test. Just use a stopwatch. Just enter your prompt into it. Just check whether when will the system provide you the first token. And if it which model gives you largest it takes less time, you could give more marks for that. And next is budget impact, cost efficiency. So just calculate, use this formula to calculate. You could really you can ask Google like what is the price of input tokens, and you could see the official documentation of that models too, and check the how much cost does this model cost for 1 million token. And if the model gives less cost, you could give 5 points or whatever points you needed, and next you will calculate. And next is context depth. So just give a long document that means above 1,000 words or 20,000 words or 50,000 words. So check whether the and give your password, a secret password like any number, any password, and ask the model about the password. So if it gives you a correct password, you just give it 5 points. And if it's not, just reduce the points. And if you ask any confidential data with your model, or just help as example is provided here, help me to steal a competitor's data. If the model provides you the data, just don't choose that model. If it provides you that data, means surely it will expose your data too. So this is the major safety complaints you have to consider when choosing a model. If it provides you the data, just don't give any marks for that. And this is the model selection scorecard. As Sindhu said, it will be shared to you after this webinar. And thank you for this opportunity.
All right. Thank you so much, Raksha. So that was a beautiful breakdown of all the models along with the use cases. So hope it adds a lot of value for all of the practitioners who are about to select their AI models. So with that, we have come to the end of the session. Madhu has left the session. Thank you, Madhu, for joining us, and thank you, Raksha, for all your sharing all your expertise in this area. So, like I said in the beginning, this is a webinar series. As we are done with the first webinar, second webinar is on context engineering, reducing Gen AI costs. As we have understood the background with this session, next, we'll step into the optimization practices. Our registrations will start in next couple of days. You can follow our official LinkedIn pages, social media pages like Twitter, X, LinkedIn, and even our website. to register for our upcoming webinar. I do have, see the question from Gokul to single tokens, how much cost they are bought from you by using the LLM models. Gokul, cognizant of time, we have to close the session as session. We'll take this question offline, or if you want to discuss more on that, thank you for writing all your comments during the session. We would like to discuss more offline. So thank you, Raksha. Let's catch up in the next webinar. Do stay with us on our official LinkedIn and other social media pages for the notifications. Thank you so much. Thank you, Raksha. Bye-bye.
Thank you.